So in this lecture, the idea is to understand how airplanes work. Okay, so you have, first of all, you have a plane. The planes can roll. This is what we call a rolling motion. They can pitch nose up, nose down, and a yaw motion is they go sideways. Typically, when an airplane is flying and it wants to turn, it turns like this. Okay, when he wants to land, it doesn't land like this. You do this to create a lower pressure at the top, the higher pressure at the top, so your plane will go down. But when he starts to land, it actually goes like this. And military aircrafts like this one, they actually land directly. So now you want to consider the gravity. The gravity is a location where my entire plane will be perfectly balanced. That's a location, a point in your entire plane structure where I can actually just place a stick there and your plane will stay completely balanced. Then you have other criteria, and I just want to go over some of the stuff that's in your textbook. So in general, in order for your plane to fly, there are 4 types of loads. You got the lift that actually responsible to push your plane up to keep it in the air. Then you got weight, you got thrust, and you got drag. Okay, these are four forces that we cannot get away with. And when we design aerospace structures, doesn't matter the plane we design, we need to know what the loads look like. And those loads actually affect every part of my aircraft, even the smallest tiny bit, a rib here, a spar there, the nose, everywhere. There are a bunch of loads here. And what happens in the loads loads group, they will develop what your load profile will look like for a typical airplane. And then once we have that load, how that load looks like, then we as structural engineers use that load to make sure the structure is safe. And the aerodynamicists will make sure that there is a flow in a coherent manner such that your plane will fly optimally. Okay, and then you also, as I just told you, there's a center of gravity. About that center of gravity, you have the yaw, roll, and pitch moments. This is in general, this is the fuselage of the aircraft, this is the cockpit, these are the wings, and these are stabilizers. Stabilizers are just that, meant to bring stability to the aircraft. If you need to have a yaw motion, then you have what we call the rudder. A stabilizing motion, you want nose up, nose down, that's controlled by the elevators right here, and they both go down at the same time, they both go up. So those elevators do this, either both go down or both go up. Okay, now this other, if you want to create a rolling motion, that's created by what we call the ailerons here at the corners, and they actually, if one goes up, the other one goes down. Okay, military aircrafts work differently, but for commercial aircraft, you have here in the corner, if this goes down, this goes up, and that would create the rolling motion. Okay. So you also have the engine, obviously. Sometimes the engines are located at the wing. Sometimes they are at the end of the aircraft. Depends on the application and the velocity. The slats, then you got flaps. These two are purposes to increase the surface area contact with the air, so we can increase the drag or increase the lift, whatever the case would be. Okay. If I look at the airfoil, the cross-section of a wing, that's what we call an airfoil. And the airfoil has a couple of ideas. This is a camber. Camber line is a location where all of this is divided rightly in one half. The dihedral angle is an angle in which your wing, if we're looking from the front, is actually with the horizontal, the wing and the horizontal, that's the angle that is created. We also have, in general, this can be tapered. You may want to take an aerodynamics course to better understand many of these concepts. In general, you got swept back. You can see this as swept back wings. There's a purpose in which they are like designed like that, because they are full of stability. They are a lot more stable. And then you also have variable wings, in which you have the maximum area when you take off for a certain application. And when you want to go supersonic, then you may want to just fold your wings back. This is a Northrop Grumman aircraft, in which actually the only aircraft I could find that has a forward wing, and has its purposes, especially for supersonic or hypersonic aircraft, hypersonic speeds. You can see the dihedral angle. This is positive because this is going up. This is an example of dihedral angle negative. It looks like a sad face. So when you have this line here, this is going negative, right? So you have those applications. And if anytime you want to create a rolling motion, right, you want to result up and down, then you need to create this force there. And that's done to the horizontal stabilizer or the elevator. Then here, what you will have is you want a yaw motion, and that's created by the rudder. I just explained that. If you want to, I'm sorry, that was a pitching moment. There was a yaw moment. This is a pitching moment, up and down. This is rolling moment, and the rolling moment then is created by having one aileron up and one aileron low to create a positive drag and decreased drag, and that will create the rolling motion. This is an example of slats, as you can see. If you have flown in an airplane and you see that the extra surface actually comes down, that will increase the surface area of contact, will help me in landing or takeoff, so I can increase my my surface area for my lift. Now, we as engineers, structural engineers, are responsible to design each one of these parts. You see, these attachments, the joints, the slat, the whole structure where this is mounted, and how this works all together coherently. We are responsible for that. And if we have engines attached, we are responsible to design all that attachment. We want to make sure that your structure is completely safe, and we are responsible for that. Now, a couple of things I want you to think, that when your airplane is actually static and is just stopping, and then he's taxiing here and he's going to take off, this part of take off like this, and then it comes to a point where he's on cruise speed. And sometimes when there's storm, and the storm is really it's intense and lots of turbulence, many aircraft, what they will do is just fly over that or underneath that, depending on the case and how severe the storm is. But typical practice is go above the storm and then come back down. So this is what your typical airplane looks like. And when it's descending, and lowering means that when you are just giving circles in the airport, and you're just waiting to have, because there's a traffic jam of planes landing. So in that case, you're loitering, you're just giving circles, waiting for your turn to land. So in our course, if we're going to design something, we're going to focus our attention mainly on this part right here, in cruise, okay? Not when it goes above the storm. We're going to stay right here in the cruise speed, okay? And the cruise speed is great, because then L over W is equal to 1, so we can assume that level flight is a straight flight, is a uniform flight, which is greatly beneficial. Okay, so this kind of sums up an overview of how an airplane flies and how airplanes work.